Just a moment. Okay, so when you double click on the Adams software, Adams view, then it will open like this. First of all, it asks for the welcome to Adams, and then it gives you the options like new model, existing model, or existing model. Suppose you want to create your own model, then you will click on the new model. If we have our existing model, suppose you are working on Adam software and you have created one model, then you close the session, and then after some time you just open the Adam software again. You will click on the existing model and you will click here, and it will ask for the working directory where you have been saved your documents or everything. Then you will ask for the file name. You will click right click and it will browse. You can browse or you can search. If you click on browse, then it will directly open the directory where you have stored your data. Suppose I have created this files previously, so you can select from this. You can select the file system is .bin format. You can see from this one, or you can open your .cmd file, .pi file, .adm file as well. So I will start from new model. Then I will click on new model. Then it will ask for model name. So we'll give the model name. Suppose you will give a name new. You cannot put a space in the model name. You need to give the underscore command. You cannot give the space. If you give space, it will not work. It will show the error. So for this we have to give the underscore. Then it will ask for the gravity. Like within the Adams environment, it already default gravity in the global y direction. So you can see from here the y direction is in this one. So it is in negative y direction. You can create your model in no gravity or other as well. I will select the default Earth normal minus global y direction. Then it will ask for the units. Here is the option MKS, MMKS, CGS, IPS. Sir, can you kindly mute your mic?
Audio கம்மியா இருக்கு.
அந்த மைக் க்ளோஸ் பண்ணிடுங்க சார். மைக் அத கட் பண்ணிடுங்க.
Hello.
எடுத்துட்டாலே பேரு.
Sir, can you kindly mute yourself? Yeah, thank you. So we have the options here, units. So you can select the MKS unit, MMKS, CGS, IPS. Default will be MMKS, that is millimeter kg Newton second degree. And here is the working directory. You have to select the working directory, like where you want to create your files and where you want to save your files. And I will save here. I'll select the folder. You can see its working directory shows C users data desktop Adams. Then we'll click on OK. There is few options, like first of all we have here bodies, then we have connectors, then we have motions, then we have forces, then we have elements, design explorations, plugins, machinery, simulation, and result. First, within the bodies we have the solids. In this solid section we have already some pre-built geometry, like the box, the cylinder, the link, the plate, the sphere, the frustum, and the torus. Some of the solids are already being created. We just need to click on that, click on the icons, and we can place it on here. Then within the flexible bodies we have the how to create a flexible body within the Adams. We can convert the bodies in flexible body. to rigid body to flexible body, or flexible body to flexible. And we can create the flexible link here. Within the construction, we have the point construction, then we have the marker, construction of geometry marker. You will see the uses of marker in the next session. And then we have the polygon, the polyline, and so on. Here we have some more options like arc, circle, etc. Then we have some Boolean operation. Within the Boolean operation, you can see you can merge two bodies. We can create a group of two bodies. Like in the Boolean, you can see unite two solids. We can select two solids and create a unit of that solid, so then we can easily manipulate the data. We can intersect the two solids. And within the features, we have some more option like the CAD tools. We have already been shown the fillet of an angle to create a hole, to create an hollow cut on a solid, and this is basically the extrude option, which is at a boss. So these features is commonly used in Adam software. Later on, I'll show you. Then within the connectors, we have the joints. Like within the joints, suppose you have created a model by yourself, and it needs to be some specific connections. So if you are doing creating a link or anything, then you have to give the joints to this to your model. So first one is the fixed joint, then we have the revolute joint, then we have the translation joint, then we have cylindrical joint, here is the spherical joint, the constant velocity joint, and create a hook joint, a screw joint, or a planar joint. These are the joints available in the Adams environment. So this can be used in your model. You can create your couples. You can add constraints to the gear. Basically, this is for the gear functions, and you can couple your model as well. Within the motions, we have joint motions and general motion. Within the joint motion, we have the rotational joint motion and the translational joint motion. We'll use it in our model. Within the force, we have applied forces, flexible connections, and special forces. Within the applied forces, we have the single component applied force. We have the vector 3-component force. We have a 6-component force. This is 3-component torque, and this is the single component torque you can apply in your model. Within the flexible connections, we have the bushings. We have the rotational single damper, spring damper. This is the field element. This is the translation spring damper. And within the special force, you can use this as a create contact. Suppose you create you create two solid. Suppose one sphere and a box. I will show you in the model how to use this contact. Suppose you create a box and a ball and a sphere. If the sphere is directly falling on that box, so in that case you have to create the special forces contact within the two solids, so that you can run your model. Then we have the model force. Then here is the field load. You can create a tire. You can create a gravity. Gravity is on by default will be in negative y direction, and you can create your own gravity. Within the elements, we have few options available. Like you can create your own function, you can create your own toolkit, you can create your data elements, like you can to create your own plots, or the matrix. Everything you can do in this element section. Within the design exploration, we have the design variables. We can create our own variables for the design measurement or anything. And we have the measure, like we have the angular measurement, we have the range measurement. We will use it later on. You can see how to use this kind of measure in your model. Then we have the instrumentation, design, evaluation, insight, and explore. These are some features available in Adams. Within the plugins, we have control, vibration, durability, and mechatronics. Later on we'll using, and you will understand how to use these kind of features. Then within the machinery option, we have the gear, the belt, chain, bearing, cable, motor, and cam. This option is very basically used for the Adams machinery environment. You will see you can create your gear pair, you can create your planetary gear, you can create your own gear test rig in the model. Within the belt, we have the pulley, the belt, the actuation in belt actuation input, and we have the chain, closed loop, the sprockets available, and the bearing. Within the bearing, we have the bearings and bearing output cables, etc. Then we have the simulation. Within the simulation, we will directly click on the settings, that is in that icon, and if we click on the icon, it will open directly run you to the simulation control. And within the simulation control, we can give your end time, you can give your step size. Like if you want to give suppose you want to simulate for 1 minute, and then you give the step size to uh, 0.01 or something, 0.01, then you can click on this and you can simulate your result. In this option, this is the animation control. If you want to simulate something, you can obviously like to see the animation, how the your thing is working, and how your model is moving. So in that case, you can see the animation, and you can see the animation control. So right now I don't have any analysis, so this error is coming. Then we have the result. This is the post processing. In the result tab, we can obviously see the animation. We can see the post processor. It will directly open the Adams Pro post processor, and from this post processor, we can see the plots, various plots, the result, the video file. We can create. We can see the animation. We can create the report. We can plot the report in 3D. Some more options are available in that is just a second. Hmm. Within the file, we can create your new database. Suppose already we are in a database file on directory, that is we have created. If we want to create our new directory, then we'll directly click on new database. We can open our new database. Like if you have created your own model before, then you can open it. You can save database, you can save as. Then we have option that import and export. If you want to import some model, like if you have created your model in SolidWorks or any other CAD software environment, then you can directly import the file. The file type available in Adams software is that .cmd, .adm. You will select the parasolid, that is basically the parasolid format, that is .xmt, .xt, txt. This is, you can obviously you can import the IGS file, the STP file. You can directly live link with the other software like CATIA, Adam, AutoCAD, or SolidWorks, etc. Here you can see the SolidWorks file .sldprt file you can import. The PROE file, that basically the Creo, you can import .prt, .asm assembly. This file you can obviously import. We'll see it later. And obviously you can export your result. Suppose you have created your model here, and then you can export this to use. You can give your name, then you can select as it is, like you have a parasolid, then you can select which kind of which file type you want, like Adams view command file, or solver datasheet, solver script, solver analysis, etc. Here is the options like STP, IGS, webfront, DAC file, RPC3 file. This file you can export directly. You can select the directory from this. Then within the edit, you can rename your model name or anything. You can change the appearance from this. Then we have the view window. Within the view window, we have these options available. You can see your model front view, back view, left view, bottom view. You can see the presentation, like zoom in, zoom out, fit. This kind of option is available. uh, then we have the render mode. If you have a model, then you can see it, the wireframe view or the solid view or the shaded view of your model. Then you can see the projection like orthographic projection and perspective projection. Within the settings, we have the working grid. The working grid is basically, you can see the dots over here. This is called the grid in Adams. You can change the size of this grid. Suppose if you click on the working grid, then you can see the spacing between this grid is 50 mm to 50 mm. You can basically increase or decrease the the grid size. I will do it. Suppose this is in 50 mm, then I will make it 20 mm. If you apply, then you will see the grid has been already increased, so the spacing has been decreased. You can change the orientation of this grid. Like this is now in y-x direction, you can change the orientation. Like you can do it in global xy direction, global yz direction, xz direction, everything you can do with this. You can give this the line to make this grid okay. And some more options, like if you have the unit already, you have defined the units in mmks, so you can change your units too by clicking settings and then you go to the units. Then it will show you how you can change your units. Like here we have the length in millimeter, mass in kilogram, force in newton, and time in second. You can directly click and change the units as your requirement, or you can directly click on the mmks, mks, cgs, ips, etc. Then we have the gravity. As I have already told you before, that the gravity is in default, that is in global -y direction, that is 9806.65, and you can change it by yourself. You can create your own gravity, or you can uncheck the gravity too. If you don't need the gravity in your model, then you just uncheck this option. And if you want to change your model, and if you want to change the gravity direction, you can change it by manipulating these options. Then we have the icons and colors. Within the icons, like I'll show you how to change the icon setting. Suppose you have created a model and you have created a joint, then you can change the icon of that joint, so that you can be visible more precisely. Then we have the solver settings. We can create our own designated solver. You can see, we can change the font, we can change the force graphics, we can uh, change the color of this color of this. Now it is in blue background, you can change it to white, yellow, or anything you want. Within the tools, we have some more options available here, you can see. So some more options is like, this is the view. If you want to do the front view, this is side view, this is the isometric view. You can choose. Suppose you have created a model, and then you need to change the view, you can click directly over here. You can click on this and you can change your graphics window with this. Then we have the material. You can modify your material library, you can create your own material. I'll show you later how to use. This is the fit model. If you are have created a model and then you zoomed somewhere and you are not able to view this model properly, then you just click on this view fit. Then it will basically uh, give you the fit view of your model. Then we have the zoom in. You can directly pick your model's area where you want to pick, and you need to zoom. So you can do it by clicking itself. Then we have the rotational control. You can click here and then you can rotate by your model with the use of this, and by clicking your middle mouse button, that is the roller button, by pressing itself. And then we have the pan option here. You can pan your model, like how to if you want to need to change something. Then we have the zoom. Then we have the zoom option. You just click on this option, and then with the help of your middle mouse button, you can zoom in or zoom out. This thing you can do. uh, With the help of Z, if you click on Z key and just by holding the Z key, you can zoom in or zoom out without clicking here. Or with the help of the R key, this is basically the shortcut. If you click on the R key, then it will you can open, you can rotate your model like this. Okay, so basically this is a quick tour and this is the model window. You know the model tree. The model tree, you can see whatever you changes you made in your model, it will be directly over here. Like if you create a bodies, if you made a body, then it will be in body section. If you make a connections, you make connectors, then it will be in connectors. If you created a motions, it will be in motions. And if you created a force, then it will be in force. This thing we will see in our next. It's very helpful and it's very important. Then some more options available in this here, that is the appearance. You can see the wireframe view or shaded view, whatever you want. If you can click on this and you can see the wireframe view or the view. So basically, this is a quick tour of your Adams environment. So any of you have any doubts in this software right now? Let me know. Next, I will jump some examples. I will show you how to do the thing. Okay. Suppose I want to create a body. Let me just working grid, make it normal to 50 mm. Sorry, 50 mm, 50 mm. Okay. Okay. So suppose I want to make a body. I will do just a second. Okay. I want to make a rigid body. Then I will click here. Then it will show you the new part. If you are doing a new part, then creating a new part, then you will select new part. If you want to add part to some part, then you will select the add part. So now we don't have any other model to add in this model, so we will use a new part. You can see I can click here and I can create the uh, side view of our model. But if you want to suppose, let me show you. Okay, if you want to give it a dimension, like if one length in 20 centimeter, heights in 20 centimeter, and depth in 20 centimeter, that it will it will show you the total diagram of your model. You just place this in here and it will open. Now you can rotate and you can see your model. This is in basically in wireframe view. If you click on the shaded view, then you can see the shaded area of your model. Okay, so if you suppose want to make another solid section like a sphere, we can do. We can click on the solid so wireframe body sphere, and then we'll give the radius suppose in 50 centimeter. Then it will ask for the placing where I want to put the put my the sphere. You can give your dimension, or you can uncheck it and you can make your own dimension like this one. Now you can see this is in the wireframe view. You can change it to the shaded view as well. This is the basics of creating your own the models. And then you, if you want to construct the point, then you click on the point. Then you can create your own point. Suppose you want to make a bar, then you can make a point over here and a point over here. Then you can choose the the path, like a first point and second point, and that will definitely create a line. And the geometry marker, the marker is basically used for, suppose if you want to if you created this one, so part 2, if you this one is called a marker, like the middle center of this model. If you want to put some loads anywhere, if you want to connect the system or your model with something, then you have to create your marker. You can choose your marker where you want to create the connections or motions that is usable for this. Okay, so I will start from a new model. I will go to file, new database. I will select no, that I don't want to save my this work. I'll select new model. We need to give the model name. I will give the name, that is if we'll create a problem, a falling stone. We'll free fall a stone. We'll see how this working. Okay, so we will create a sphere of radius is 10 centimeter, and we will place it. We will change the view in shade. You can see the model, its gravity is in, you can see the arrow. This is shows the gravity of your model. Then we will do one thing, which we will click on modify, and we will give the name. The name will be, suppose if a stone, suppose this is a stone, and okay, oh sorry, I can't change the name of this part too. We can modify. Suppose the mass of this defined by material type. There is no material is selected. We can give our own input. We will click on the user input. Then you will ask for the mass. Suppose I want to give the mass of 5 kg. Then we will click on OK. So if we simulate this one, suppose this is a stone and we have given a mass to the stone. If we simulate, what will happen? It will definitely free fall. So that thing we can simulate as well. We will click on the simulation, and with the end time of 2, and we will step size is 0.1. If we simulate, it will free fall. You can see this thing is falling from the center. This is a very simple model. This is a very basic model, how to use the the system, and this is the simulation control. You can check. You can click here, and you can see the animation. If you click here, it will animate. If you want to make a trace, you can go to the trace maker, and then right click here. Then we'll select the marker. Like this marker, we can select. Like we will see the trace of the free falling. Then you can see the trace here. So you can see the trace. Okay, I'm recording the session totally. I will send to you, and I will obviously give you a whole PDF file where the simple problem has been created. I'll show you how to use this one. Just a second, I'll show you how to use the PDF to learn by yourself. I will give you the basics idea, and later on you can use, I will give you this book, and here all the models is available. You can just let me show you. From the section 1, that is in beginner level, you can see in this model like how to do this model here. Or everything is being written, like step 1, step 2, step 3, step 4, and you can see the images, and you can make your own model, and you can practice, and you can learn how to use the CAD software. Like if you zoom in a little bit, this is visible now. You can create your model by just it shows the steps, like click on create new model, then it will go for model name, change the falling stone. For the gravity, choose the arch normal. For unit sets, mmks to mmks degree. Everything is written and in step by step you can use, and lots of options of lots of model is available, like the beginner level, intermediate level, uh, and you can see some 13 problems are available, and some examples are having too, so you can use it later. I'll send it you now. I will okay, so then we'll what we'll do, we'll make a simple 4-bar mechanism, like see how things will create a new database. So everyone can understand the basics, how to use this kind of software. Like if you are getting some idea, let me know if you are having any trouble in the basics. Okay, because if you learn the basics, if you can learn the basics, then you can do it. The uh, models by yourself. It's very easy. We'll choose a new model and okay. So we and what do we will do a 4-bar mechanism. For this we will do 1 bar by this y direction and 1 bar will be in x direction, and there will be a connector link will be there, and if we will give the motions and it will simulate, we will see the simulation and result. So for first one I will select the rigid body link. Was I have selected this bar, created this bar. You can see the link this one, and if you click on modify, you can see the width depth of the link. As I have not selected any the dimension, so this one is measured the dimension, what is it. Then we'll select another bar, then we'll choose and this direction, and we will create another link like this one, and another bar with this. Okay, this is a simple 4-bar mechanism. I'll be making 4-bar mechanism, and we'll see how this rotate. If we give some motions in any of your joints, then it should rotate. So for this, what I have to done, I have to create the contact with this part. Like this one is part 5, this one is part 4, this is part 3, and this is part 2. So within the part there is no contact has been created, like there is no contact. So first of all I have to create the contact within the parts, like we have to create the joint. So for this we'll go to the connectors. What we'll do, we'll choose the revolute joint. Like if it's moving towards this one or this side, then it should be a revolute joint. If we create the the fixed joint, then the bar will not move properly. It will not move, it will, because it will be fixed. Then we select the revolute joint. Then it is asking for the first body and second body. First body should be, if I want to create within this 2 parts, then we'll select the first body as part 5. Then it is asking for the second body. You can see over here, it is asking for the second body. Select the second body. Okay, select the second body. Then it is asking for the location, like where I want to create the the joints. You can, if you uh, move your mouse over here, then you can see some of the points that are available for the joint. Like within the two part, part 3 and part 5, three marker are already created, like in the middle, like in the side, and the middle and the side. So I want to create the joints in this part. So I'll click on. You can see within the connector tabs, the joint one has been created. The joint one itself, you can see with this logo, this is the joint one. Then we'll do the same thing with the others too. We'll select a joint, revolute joint. We'll select the part 5 and part 4. Then we'll select the marker 6. That is the middle of the joint. So joint 2 has been created. This one is a joint 2. Then we'll create another one. We'll select this part and this part, and we'll select this one. And the last one, revolute joint, click part 2, part 4, and choose this point. Okay, so I have created the connectors. I have created 4 connections. But one thing you have to define, that is the fixed joint. Because if you simulate this model right now, it will free fall. Because I have not make any constraint like the fixed constraint. I have to make something fixed, like I can fix this one or this one or this one, so that the model will not free fall. So that's why I will do one thing. I will do a fixed joint. I will select this part with ground. If you move your mouse, you can see the ground. I will fix this one with the ground, and the position is in the middle. So you can see the logo that is in fixed constraint. So if you give the force, if we create a force in this model, then it will, it should rotate. Like it will not free fall, because I have already given the the fixed constraint in any of your component. So then we'll give motions, like I will give motions of the revolute joint motion, rotational joint motion, sorry. I'll click here and I will choose this joint. You can give the motions to joints only. You cannot give motions to the element, or you cannot give it to any part. You can create your joint, you can give your motions to the joint only. In that case, I will give the motion in joint 1. So you have see within the motions, this motions has been created. So if I modify, then the function is defined as 330 degree. I will choose it to I will do 720 degree, 720 degree. Okay, and the type, I will choose the velocity. I will give it the velocity, not the displacement. Then I will click on OK. So now my model is okay. So now it should simulate. Then we will go to the simulation tab. Then we will go to the run interactive simulation. We will click here. Then we can give the end time, that is for 2 seconds, and the step size 0.01. Then if we click on simulate, you can see the simulation of your model. Before proceeding, if you have to check this one, because reset before running. Suppose you have run your simulation, you have already simulated your result. Then if you want to simulate it again, it will not simulate. So you have to click on this one, like reset, or then you have to simulate, or you can do one thing, you can reset before running, you can check this option and you can simulate. From this window, you can select the animation, go to the animation control. You can go to animation control and you can see the same animation with by clicking this. I have make it very fast, so that's why it's rotating very fast. Okay, then if we go to the result tab, then we have the post processing. Within the post processing, this is the post processing window. So within the post processing window, if we click over here in this option, right click, you can see we can choose our window. Suppose right now we have the only one window, we can select it two window. We will see the result in one animation in one window and plottings in another window. So if you click over here and you can select three plot, you can see the three is been created. So if I click on this right one, then what I'll do, I will click load the animation in this plot. I'll right click here and load animation. What animation I do want, this animation I have I have imported in this tab, and within the right tab I will see the the motions or the curve. So what result I see the body part 3, 1 2 3 or 4, part 3. I will see the angular velocity, acceleration constraint. Lots of options are available. I will be selecting some options so that you can see the uh, position 3. Okay. Okay. So what I am seeing here, the part 3, central mass position in the X component. You can see the plots over here. If you simulate this one, you can see how the plots is being created and how the animation is you can import your data from here. You can choose, I'll select to pause. You can to import your data from here. You can see various plots are available, lots of plots are available, you can see. So this is the post processing. We'll do it more later. We'll do some more practice, and this is the very basics of a simple 4-bar mechanism. Then we'll do some more examples problem so that you can understand this very clearly. This is the 4-bar mechanism. Then we'll do one thing. We'll do a ball and a box, and we'll try to fall the box on the to try to fall the sphere or the ball in that top of the box, and we'll see the animation or result. So I'll do one thing. I will file new database. I don't want to save this one. I'll select new model, click on OK. So what I'll do, I'll create a box first. I'll create a box. Suppose this one is a box. Length, let increase some more. 4. This one is a box I have created. This is a front view, so that's why it's showing in 2D. This is basically in 3D. I am if you see the isometric view, you can see it in the isometric position. So, and I'll create another sphere. This sphere I want to fall in this box. So I'll choose this one sphere and I will select. So you can see uh, the ball will be falling in this box. So if you see the side view, you can see the ball is let me change the radius of this ball. It's right. I'll create a ball of 3. Okay. Okay, so you can see the ball is not in the center position. So what I will do, I will shift this ball to some forward in this direction, that is in Z direction, so that the ball will fall properly. It will not fall in this direction. So I will choose one options here. I will select this one, select this model I already selected. Then I will choose this one, no, this option. If you click in this option, you can see some options arrived. That is rotate about the view center. You can translate your ball from in this direction or upper direction or left direction or in the direction. You can choose the distance. Here it is in 10 centimeter. You can increase it or you can decrease it. I will choose 2.5 centimeter and I will click here. You can see the ball is moving towards this direction. You can see now the ball is in position. If we see the top view, you can see the ball is in the middle position, so that it will be fine. So you have seen this option is available for moving your parts freely. Okay, so I have created this box and the sphere. Then what we'll do, we have to create contact. Okay, we have to create contact with this solid to this solid. For this we will go to the forces. Within the special forces, we have these options like create contact. We'll go to create contact and here's the options contact type. You can select solid to solid, curve to curve, point to plane, curve to plane. Lots of options available. In this case, as it is in solid, this one is solid and this one is solid. I will choose solid to solid contact. Then it will ask for the solid 1 and solid 2. That is in I and J. This is 1 and 2. So for this, I have to pick this one. You cannot pick, just click here and you will cannot pick in this way. You have to click, right click over here, contact solid, then you will click pick, and then you click here and it will select the ellipsoid 2. And this one, same way, you right click over here and create contact, then you click on the pick, then you select this one, the box. Now the contact has been created. Here is some more options available like force display. You want to choose the color, red, blue, steel blue. I choose it in yellow, pink. Okay. Then you have the force options, that is impact, restitution, and user defined. Within the user defined, you can select your own function. I will select as it is impact, and you can see the stiffness, force exponent, damping force, penetration depth. Everything is already predefined. You can change it or by yourself. Whatever data you need, you can manipulate. I'll click on OK. So you can see the contact has been created. So if what happen if we simulate it right now, so if we simulate it right now, as I have already shown you that this is not any constraint has been created. Like if we are not constrained anything, it will free fall. If you, let's simulate this one. If you want to simulate this one, suppose these two things will free fall because you have not created any fixed constraint in your model, so it will free fall. Both will free fall because it's already contains some amount of mass. If you go here and right click over here and select the modify, then you can see there is already some mass has been already with some mass like 0.88 something, you can see. So what you have to do, you have to fix one thing. So I want to fix this box and I want to fall this sphere in front in this box. So that's why I will do one thing. I will create fixed with the the ground, this one. So I'll go to connectors and select the fixed joint. I will select part 2 because I have to put the first body, that is part 2. then we'll move your cursor and it will show ground, then we'll select ground and it will ask for the location. We'll see the middle of this part 2. You can see if you select the wireframe view, you can see you have okay, this one is your fixed joint, that is fixed. Okay, so another thing is settings. You go to settings, you go to icons, like I have told you previously that if you click on icons, the icons is basically these icons. If you want to reduce the icons, like if you are if you can see the icons is very big in size, so I will change it in smaller section, small size, so that it will not impact the model. That new value on, and the new value size I will choose 10, then I will click on OK. You can select, see the icon has been reduced. Okay, I can do one thing. I can create this box as a the ground. I can create this box as ground too, or I can fix that box with the ground. I have fixed that box with ground. So now I will simulate. I go to the simulation control, then I will select the end time of 2 seconds and I will give that step size and 0.02. Now if we simulate, the ball will fall. If you see the animation again, we'll see the ball, the free fall of the ball, and it will create a force. If you go to the result tab, then to the post processor, you can click over here. You will choose the animation, load animation. We'll see the animation, and in this one we'll see the force in the contact. If you animate this one, you can see the graph. You can see the force is almost 1500 Newton in this direction, and in the time of, if you click on this, if you click on this one, that is the plot tracking. If you click here, you can see in this time the force is the highest, because in the time of impact. There is some more plots are available. You can choose whatever you want. I will, let's see some contact element in magnitude curves. Okay, so these are the options available in the post processing. So anyone have any doubts in up to this? Let me know how, if you have any doubts. Am I clear right now? Like what I have shown you, is that clear to you? I'm just trying to give you the basics of your training, so that you can do your model, your complex model by yourself. And there is lots of options available. You can learn. You can do your the complex model by yourself. Okay, so now we'll move. I will do some more examples so that you can understand how to use. We'll make the simple pendulum problem. We can we will do the single slider crank mechanism. We'll see the double slider crank mechanism. We'll see how to use these tools and how to create these models. I'm just trying to give you the example so that you can understand how this thing, how to create the model or how to build this model, and how to simulate, how to get the result, everything. Okay, so I will go to the file. I will create a new database. So I will do one thing. I will do the simple problem. Just a second. Add-ons. Actually, the session is recording, so that's why my system is getting some lag. No issue. You can see what we have in here. The table of contents we have in beginner level. We have some examples: falling store, incline plane, lift mechanism, spring, the suspension system, four-bar mechanism. Okay. Okay, we'll select a new model. We'll go to as it is. First of all, we will create a link. So this is a simple pendulum problem. There will be a link, and in the last position there will be a sphere. And what I will simulate, I will give it some time for the movement of the pendulum, and we will simulate the result. For this, we will create a link. Link length will be let's see 450 mm, 450 mm of length, and width will be 27.5 millimeter, 27.5 mm. You have to keep your data in bracket. Rather than this, it will not accept. It will give some error. 20 meter. So the link is this size. So if I click in the middle, then it will create by itself, because it will not give you the uh, give you choose the second position, because I have already created the dimension. This is only for the position. I will make it shaded. Then if you have to create a sphere over here, so I will click on sphere. Its radius is 25 mm, 25 mm. And what I'll do, I will not create a new part. It will be add to part. I will check the radius and we'll select this one. I will change the color so that you can understood. Ellipsoid. I'll go to appearance. I'll go to appearance. Then there is colors option. I'll right click and then we'll go to color, and we'll, in the gases I can choose red, and you can see the color. Let me change it. So you can change the appearance by clicking right click and appearance. Then if you want to change the color, you have to right click over here, then go to color. Then if you have a the color file, you can browse, or you can select the gases is already in the Adams software. This color is already available. You can choose your own color. You can set the transparency, like the link one is selected. If you want to make it transparent a little bit, then you can change the transparency. I will make it transparent up to 60%. So you can see the transparency, it's now a bit of transparent from this one. So you can change the appearance from right clicking over here. Then we have to change the mask property. I can rename this one. We can give the name as pendulum. Okay, you can see the name has been changed. We can right click over here and we can modify. So what I will do, I will give it a mask. of 2 kilo, and I will change the inertia of IXS 0, IY 0 and IZ 0. So how you can do it? Right click in pendulum, like you renamed it in as pendulum. You go to modify, you go to user input. Suppose here is it in geometry and material type. Here material type is in steel. You can change your material by right clicking over here. You can browse, or you can give your own material. You can guesses. Within the gases, we have the revealed material is available, that is aluminum, cast iron, steel, stainless steel. Lots of material is available. If we click over here and we will give the user input, like I want to create my own mass, I want to give the inertia by myself, then I will go to the user input. I will give it the mass of 2 kilo, 2.0, and I will choose the inertia as 0, 0, 0. I'll click on OK. Now the center of mass of this link is in the middle. Center of mass means I want to put the loads, all the loads over here. I don't want the marker is over, in this direction. So you can see, if you click on the marker, center of mass, this is center of mass. Center of mass is in the middle of this link. So I want the center of mass to be here. I'll click on the CM. CM stands for center of mass. I'll click, right click, I'll go to modify. Yeah, I'll go to modify, and I'll give the locations, that is in 270.362, that is in X direction, in this direction. I want it here. So it will be 450 mm, like 450.000, because you have seen the link size was 450, length was 450. If you click on apply, you can see it has been shifted over here. We'll close. The model has been created. Now what we'll do, I will create a revolute joint. I will create a revolute joint. I'll create a revolute joint. I'll click on create a revolute joint. First body is pendulum, that is this one, and second body will be ground, and the location will be middle, this one. I want to rotate this one in this direction, so it will rotate. Another thing, will select the measure right in the joint. I want to measure. I'll click on joint, this joint. I'll click on I'll click on measure. Measure means if you want to see the result, or you want to you want the measurement, like I want it is, and force along X direction, this one, and Y direction, this one. Else, okay. So what I am measuring, uh, the time versus position graph of X direction and Y direction. Then what we'll do, we will construct a marker over here, because I want to simulate this up to this position, and I want to see the result up to this position. So what I'll do, I'll create a marker over here. So for creating a marker over here, I will go to the bodies, and within the construction tab we have the marker options, that is this one. We'll click on marker, then it will ask for locations. You can see over here it will asking for select the location. If I click here, it will get this location. So I will give it a location. I will right click over here, then it will give me a message that is the location event. So I will do one thing, I will give it x0, y is in minus 450. So minus 450 means the distance from here is 450, and I want to move this one up to this, so that will be 450, that is a minus 450. So I'll make it minus 450 and click apply. You can see the marker has been created. So we will see the angular measurement, like this one we will see the angular measurement. So for this what we will do, we will go to the design exploration and we will measure the angular measurement. Select this one, we will go to advanced, like this. Then we have to give the name, like you can give your own name. Right now it is angle underscore one, let it be the first marker. Then we have to choose the first marker. The first marker is the pendulum. If you click over here, you can create the guesses, like there is only 3 marker available, so that's why it shows all the available marker. Model 5, marker 5, marker 6. You can browse or pick. I will choose pick, then I will select this pendulum center of mass. This pendulum center of mass, that is the middle. Okay, the middle marker will be, the second marker will be the pendulum 1, the pendulum marker 1, pendulum marker 1, this one, and the last marker will be this one, pick crown marker. I will click on OK. So you can see the angular measurement over here. Then I have to mention the initial position. Like the initial position, if you click on the joint one and right click, and if you go to modify, if you click on the initial condition, I want to give it a rotational displacement of some value. Like I'll click on the rotational displacement. I'll give a value of minus, suppose minus 85. So if you click OK, OK. So you have the rotational displacement of minus 85 and minus direction. So if what happen if you simulate this one? So if you simulate it right now, then you can see for the step size of 0.01, I'll simulate it for 2 seconds. I'll go to uh, there is some error in my model. This constraint equation had become almost an example. The model person, I think I have created some mistakes over here. So let's see what could be the error. Joints. Okay, the joints will be here. You can see, I think it should be here, the joint, because it should rotate in this direction, so the joint should be here. That's why that could be the problem. Let me check once. I will delete this joint. I will go to connectors, select this one, first body pendulum, second body ground, this one. Okay, I'll go to joint, go to measure in X direction, to joint, measure in Y direction. Okay, I'll click on the joint, go to modify. The initial condition is rotational displacement of -85. I'll click on OK. Okay, so let's simulate it again. Okay, you can see the result. So what was the mistake you have? I think you have noticed that I have created the joint in the in this area, but the joint should be over here because it should rotate in this direction with the center, this one. So that was the problem in our simulation. If we simulate it again, you can see the chart over here. You can see after the time it's uh, getting in this direction. If you go to the this result section and go to post processor, if you click on this, you can load animation. You will select load. You can see here we will create we'll see the curve. You can see the curve. If we click, you can see. So what we'll do, we'll change the angular displacement that angular displacement from 85 to some more, and we'll see how the result is affecting. From 85 we'll choose let's say 180. Okay, simulate it again. You can see the changes in your graph, like in the previous this was moving up to this, and now you can see it's moving this way. In that way you can manipulate your data, you can change your data, and you can play with your simulation as well. This was a simple example of this the simple pendulum operations, and next we will see some more examples like single slider crank mechanism. So any one of you have any doubts over here? So let me quickly respond to your. So anyone have any doubts? I will send you the recordings of the session as well, and obviously I'll send you the PDF file so you can practice by yourself. You'll obviously you will get some the inputs from the PDF. Okay, let's get back to. Now we'll create a single slider crank mechanism. I'll go to file. I'll go to new database. Do yes. So I am showing you this kind of examples for because it covers some of the operations in Adam software, so that you can understand how the options is working, how the operations is working, and when to choose what kind of the options. Uh, for this, I am just giving you the examples, and I am doing it by myself so that you can understand the steps I am doing. You can write it down, or you can get it in your recording, in my recording as well. Okay, we'll go to file. What we'll do, we'll do a single slider crank mechanism. That's why what I'll do, we'll create a link over here. We'll create a link.
evening வந்து பேசுறேன் வீட்டுல.
Yes madam. Hello.
Sir?
Yes madam.
Okay.
May I continue?
1 minute, sir. 1 minute, sir.
Okay, okay.
You can continue, sir. Sir, you can
Okay,
continue.
okay, okay.
Okay, sir. Right, sir.
Okay. So in the single slider crank mechanism, what I'll do, I'll create three link and a slider, and we'll simulate the slider crank mechanism. For this, I will select a link. I'll click on the link. Then I will okay. Let's just do one thing. I will change the grid size, the working grid size to 20 mm. 20 mm. I'll click on OK, and the units I will put it in a radian, because I will give the the motions in radian, so I'll choose it to angle radian. Then click on the link, and I will give it the size of length 10 centimeter, width of 4 centimeter, and depth of 2 centimeter. I'll click over here, and I'll fix it in 45 degree. I'll create another link, click over here, another link of same dimension, and the length will be 40 centimeter. Then I will choose this position marker at the middle of this this link. I click over here, and I will place it over here. The two link has been created. Then the third link will be in this direction up to uh, this direction. So I'll click over here. I will uncheck the length, because I want the length to up to this one. So you can give the length by yourself, or you can choose it from your cursor. So I will create, click over here, and you can see I can increase it. So if you have uh, created the uncheck, you have unchecked the line, so you can increase it. If you have checked the line and give your dimension, then you cannot increase it by yourself. You have to give the same, it will give it by the same amount of the dimension is already written. So what I'll do, I'll create another box. I will create a box of length um, 8 centimeter, height of 10 centimeter, and I'll place it over here. I'll place it over here. Okay. So this is the simple slider crank mechanism. My model has been created. So what I will do, I will create a joint. I will create a motions. For this, I will have to give the joints. So I have to give the revolute joint in this portion, and this in this portion, and a translation joint, because it will be moving. This box will be moving through this direction to this direction. For this, I have to give a translation motion over here. So I will click on the connectors. I'll go to the revolute joint. I will select the part, this portion and this portion, because I want a revolute joint over here. I'll go to the revolute joint. I'll simply click on part 4 and part 2, because I want to make another revolute joint over here. Then I'll create another revolute joint on part 3 and part 4 in this point. Then next we will create another translation joint, that is a slider joint on the box with this one. because the box will be moving in this direction, in negative x direction to positive x direction. So I have to give a translation joint. I'll click on the translation joint. As it is, it will ask for the first body and second body. The first body will be this one and second body will be this one, and I'll choose this. And what will be the direction? It is asking for the direction, so I will choose center mass of y, because the box center mass is in the middle of this and it will be in this direction. So now my joint has been created. Now what I'll do, I will create a motion. I will give a motion to this model so that it can simulate. I'll go to motion. I'll give a rotational joint motion. I will choose this joint, because you should have a joint to give the motions. I'll click over here and it will join. So if you click on the motion and right click in the motion, and if you go to modify, you can see the function, this one. I'll do the rotational speed and 30. Okay, let's simulate this result, this one. If you go to step size 1, you can see there is some error in my model. Constraints, some constraints is missing. So just a second. Okay, for the time being I will open my already predefined database, because it's already 11:48. I have Adams training. It's very easy. Single slider mechanism. Okay. Okay. Let's simulate. Go to simulation. Simulation control. You can see the rotation of the slider. I have given the duration of 15 seconds, so that's why it's rotating in this way. You can you may go to the animation control and you can animate. You go to the result tab, you go to post processor, you load the animation. You will choose here we have two result, two analysis. So like let me show you. If you check the see the result tab, I have created a two simulation, like last run and result. So for this it's asking for which animation you want here. So I'll click here and load animation. That's why it's giving me this option, which animation you want. Right now I will choose the last run. I'll click OK. I'll go to plots. Let's see the part 1, part 1, 2, 3, part 2. See the angular position, dude. If you simulate this, you can see the length by time graph of the part 3. That is the part 3. That is part 1, 2, 3. That is the part 2 I have selected. So you can see the result. You can export the the animation file as well. You go to the record option. You select. You give the name. of slider crank, already given file name slider crank. You can change the format, AVI, MPG, JPG, everything. You click on recording. Its recording will be saved automatically in your directory. You can see it's blinking, like it's recording the session. It's not a recording session, it's recording the animation, so that's why it's getting some lag over here. So I will choose stop recording, and if you go to my directory, you can see this animation has been recorded. If I open this animation, you can see the animation over here. This is important for your, your project submission or any report submission. You can build your model, or you can send it to your seniors or your colleagues, so that they can understand what is the your simulation status right now. This is very important. Okay, you can export your data. You can, suppose you want to export this, the graph. So what we'll do, we'll create on file, we'll go to export the HTML report, and it will create a HTML report of your entire analysis, and we'll still give the output directory. I'll click on search and browse. We can give the output directory. Suppose Adam's training, I'll open, I'll give this one as output directory, and then I'll change the parameters like image height, image width, aspect ratio, the movie format. You can choose the models. What is the name of the models is here is all in single slider clamp mechanism. You can include your design points, include markers, and you click on OK, and you will be created report. So if you click here, the plot tracing, you can see here, you can see the plots trace. You can see the x y direction, slope. You can see this is under the post processing unit. You I'll click here, go right click, not copy to file. I can import. What I will do, I will take this image, and I will save it. I'll click right click over here, I'll copy to file. I will give it a name, Adams training single slider crank mechanism. I'll click on file name is new. I'll save. So if I go to my directory, you can see the file name new has been created, and it's in JPG format. The plots is being exported. Okay, so some more features like, oh, we'll go to file new database. So today we have seen the 4-bar mechanism, the contact forces of two solid, how to create contact forces, and some more examples like a single 4-bar mechanism, single double cylinder. Now I will choose I will do another problem of double slider crank chain. Let's what I'll do, I will create two link in this direction and this direction. I will go to link. First of all, I'll change the grid size to 10 10. Okay, then I will press F4. F4, it will show me the coordinates. If you press F4, it will show the coordinates. Like if you move your mouse, and it will be uh, showing the coordinates over here. Okay, so I will create a link. I will make it as it is. Suppose in this direction a link, and another link in this direction. Then what we'll do, we'll create uh, one more slider over here of let's see, 10 10, let's 15 centimeter, 15 centimeter, and we'll place it over here. We'll do another slider here, and we'll create a link. We'll create a link over here, and this to this. This is as simple as double slider crank chain. Okay, so in this model, what we have to do, we have to create the slider joint and revolute joint and fixed joint. In this example, you will see how to give the connectors. First of all, we'll go to connectors. We'll give the fixed joint this part with the ground in this area, another fixed joint in this part with the ground in this area. So this portion is fixed. We have to create the revolute joint and the translation joint. We'll give the revolute joint in this box and this part over here, another revolute joint, this part and this part in this position, and we have to give the sliding joint in the box with this link so that the box can slide. We'll go to the translation joint. We'll click on the box, that is this one, part 5, and this link, part 3, and we'll choose this. And we have to give the the in which direction it's okay. We'll choose this direction. The box will be moving in this direction. Then we have to give another translation joint. We'll click on this box and this link and this one and in this direction. Now what we'll do, we'll give the motion a rotational motion. Go to motion goes in this joint. So what happens if we simulate? We go to simulation, two step sizes. You can see if we simulate for some more seconds, you can see the simulation, and the same way you can choose the result. Let's do one thing. Post processing. The same way you can can click in this, will load animation. Over here we'll select the model body part 1 2 3 or 3, position, magnitude, part 1 2 3 4. Let's say part 4 in the center of mass position, and within this part 5 center of mass position. If we simulate, what we'll see, you can see the position magnitude of this part 4 and part 5. Okay, in this way you can do lots of things in post processing. You can choose any marker point, you can see the result in here, and you can create your the trace mark. If we, let's see how, if we can make that trace mark. We'll go to this. Okay, let's simulation, go to simulation. We'll see the trace mark. We'll see the traces, like trace marker. We'll keep the marker for 1 2 3 4 2 marker. Fish. Okay. Click marker. Cut to. You can see the trace maker icons. Okay, you can manipulate the animation as per your requirement. So basically today's agenda, I have completed the basics, very basics of Adams software. Next day I will do some more examples on Adams car, or I will simulate a slider crank, a cylinder piston mechanism, and we will see how the cylinder piston is moving, and we will see the result, various types of plots, and some more problem on beams, like the beams problem we'll see. So any questions right now, let me know. If you have any questions, I will try to answer it, or today or later next day. So if you have any questions, let me know, or I will end up this session today. This is very
Sir, you have explained that,
yes.
sir, you have explained not for the dimensions. Simply you have shown all the things. The
Yes, madam.
dimension.
I didn't mention any special dimension. Like, this is very basic, so that's why I didn't mention. If you have your own model, you can create your dimensions.
Okay, sir. Right, sir.
Okay,
Right.
let me show
Okay.
you. If you have create, if you want to create a body, suppose in a link. So here I have chosen a normal random number. So you can
Yes.
give your length, width, depth as per your design, as per your model specification. Okay.
Okay, sir. Right, sir.
Okay.
So we'll practice it and
Yes,
you
madam.
keep.
You just practice. I will send you the PDF file and the recording as well, so that you can practice. And it's very easy software. If you get
Yes.
some more practice, do some more practice, you definitely understand.
Okay, sir. Okay, sir.
Okay,
Okay.
okay. Thank you,
Okay.
everyone.
Thank you,
We
sir.
have this session, and we'll see you next day at the same time.